Hey everybody, we're back. I'm here with my assistant, my daughter. Hey guys, Lizzie. So today we are working on activity 13.1 in Iqwst, and this is testing the properties of our soap. You might remember we made our soap using fat, sodium hydroxide, and rubbing alcohol. Lizzie heated those up, and then we let them cool off in some salt water to harden. Then we removed them from the salt water, let it dry out. So Lizzie, if you could show us what that looks like now.
Sure thing.
So we're using gloves, or we're wearing gloves, because we're not sure all the sodium hydroxide was used up in the reaction, and we don't want to risk getting any of that on our skin. That's not going to prevent us from testing the properties today. As you know, and I hope you made your table already, we are testing color, hardness, solubility, melting point, and density of our new soap. Now that's a lot to test on such a big piece of soap. So what should we do, Liz?
We should cut it up into slivers.
Okay, so we're going to allow Lizzie to do that with the scoopula. Okay, now that you've cut that up, Lizzie, we have a few tests to do. The first thing is color. Can you tell us about the color you see?
So it's a very light pink, almost a white.
Okay, terrific. I hope you're recording that. Then hardness. The textbook says you should pick it up and give it a squeeze and tell us what it reminds you of.
Sure thing. It feels kind of like butter.
Okay, and remember, we've tested the properties of fat and soap before. You can compare our new soap to the kind we tested in the lab. Now the next test is solubility. And tell us about how you're going to do that.
So I'm going to use warm water that's not room temperature, like a little bit warmer, in a test tube. And then I'm going to put a piece of soap in, and I'm going to shake it for 30 seconds.
Sounds good.
Safety first, Mom.
Sorry.
So there's my warm water, and I'm going to put this piece of soap in, and I'm going to cap it, and I'm going to shake. Will you keep the time on?
Sure. And 30. Okay, Lizzie. So the way we did this in the lab was we opened it up to take a look to see what you said. But if you could take a look at our test tube first, what do you notice?
So there are some bubbles at the top, but there's still quite a large piece at the bottom, so it didn't all dissolve. I'm sure that if we shook it for longer, it probably all would dissolve.
That sounds about right. So when we recorded solubility, we want to say it's mostly soluble in water?
Yeah.
Okay, terrific. Thanks. Our next test is for melting point. Now we tested the melting point in the lab of fat and soap. And for fat, we get somewhere in the 40s. You guys have this data. But for soap, we found we couldn't make it melt. We're going to see if we can make this soap that we made, this new substance, if we can make it melt. And in order to do that, we've set up this apparatus. Once again, we have a burner going here, or a hot plate going here with some hot water. And then we have our burette clamp with a test tube attached. And we'll put some soap in there, and we'll use our thermometer probe. And when the soap starts to melt, we'll tell you guys what temperature that was. Sound good?
Sounds great.
All right, let's go. Okay, Lizzie, so now we have this water is boiling. We can see it's a lot of bubbling going on.
Some steam.
Yeah, and I'm looking at this thermometer now, looking at our soap, it doesn't seem to really be melting much. There's not a big change. And we're already up to 69 degrees Celsius. So
yeah,
I think we can safely, 70. I think we can safely say this melting point is greater than 70 degrees Celsius, and we'll call it a day. All right, so that takes care of our melting point. The last thing we need to test is density.
Sure.
And you know for density there are two values we need.
You need the volume, the initial and the final volume, and you need the mass. So the mass of whatever you're putting into your water for the water displacement theory.
Right, and as you mentioned, we are using water displacement because we don't have a perfectly shaped piece of soap. All right, so let's go ahead and you can go ahead and get the mass of our soap. So tell us a little bit about what you're doing there.
Right now I'm hitting the 0 button on the balance. I'm making sure that the mass of the whey boat isn't taken into account when we measure out the mass of the soap.
Okay. And so then what is the mass of your piece of soap you're going to use for this test?
The mass of the soap that I'm using for this piece of test is 1.3 grams.
Okay, so 1.3 grams for our soap. All right, now we have that recorded. The next thing you said you needed was?
The initial volume of the water in the graduated cylinder.
But we're not using water in this case, right? We're using rubbing alcohol.
Yes.
So the rubbing alcohol initial volume?
It's 50 milliliters.
Okay. And since we are using a solid today, we're going to say cc's, or cubic centimeters.
Yep.
As you know, a milliliter is the same thing as a cubic centimeter for our purposes. So I'm going to go ahead and write that down.
While she does that, I'm going to put the soap into the graduated cylinder.
Okay. So now we've got that. You've added the soap to our rubbing alcohol in the graduated cylinder.
Mm-hmm.
And what is that final volume?
The final volume is 52 milliliters, or cc's in this case.
Okay, so with that subtraction, we know that the volume of our soap would be 2 cubic centimeters, or 2 cc's.
Mm-hmm.
Now the equation for density is mass divided by volume.
Mm-hmm.
So if our mass is 1.3 grams and our volume is 2 cc's. Okay, so when we do those calculations, we come up with 0.65 grams per cc.
Mm-hmm.
So if we had put this in water, it would float.
Yeah.
But because you put it in the rubbing alcohol, it's going to sink.
Yeah.
So now we have data for color, hardness, solubility, melting point, and density. If everybody's got that in the table, go ahead and move on to the conclusion portion. Thanks, Lizzie.
Bye, guys.
Bye. See you later.